Great seeing you here again. My name is Luc de Koster, founder of the Koster Academy, and in this video I talk about the standard for project management, the project management principles, and we will discuss Principle 8, build quality into processes and deliverables. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look at quality. When we look at quality, it's in fact a very important element, and what we have to do is that we have to maintain focus on quality that produces deliverables that meet project objectives and align to the needs, uses, and acceptance requirements set forth by relevant stakeholders. Quality is very important, and quality can be defined in different ways, and we will look deeper into these things during this video. But first of all, when we look at quality, we have to talk about satisfying stakeholders' expectations and fulfilling project and product requirements. We also look at quality. We have to have the main focus of quality, which is meeting the acceptance criteria for the deliverables. We have to ensure that processes are appropriate and as effective as possible. But let's first define quality and grade. What is the difference between quality and grade? Quality is the degree to which a set of inherent characteristics of a product, service, or result fulfills the requirements, and it includes the ability to satisfy the stated or implied needs of the customer. Things are related here to the customer, to the people or the organization that will receive the project outcomes. When we look at quality of deliverables, we measure them related to conformance, to acceptance criteria, and fitness for use. On the other hand, we can talk about grade. Grade and quality are different. Grade refers to the price of a good or a service. A high-grade car, expensive, can be low quality, and a low-grade car, a cheap car, can be of high quality. Look at Toyota. They were low-grade cars. They were quite cheap, but they had a high, or still have, a high quality. When we look at dimensions of quality, we look at different items that we have to consider. First of all, we have to look at the performance. Does the output function as intended? Conformity, is it fit for use? Is it compliant with specifications? Reliability, repeatability of the metrics. Can we repeat those metrics? Can we find reliability of our product? Resilience, how does it cope with failures? Uniformity, what is the parity with other deliverables? Efficiency, maximized output or input. And finally, sustainability or positive impact. Cost of quality and processes. Now, quality is not for free. We have to pay for quality. We will see that later in one of the slides. But it's also important that we should not overpay to get a higher quality level than necessary, unless it will give us an important advantage. People pay for a certain quality level. If you provide a product which has a higher quality level, it may be very interesting. It will probably cost you more money, but the customer doesn't need it. So the customer will not pay for the higher quality because they didn't ask for it. Now, when we look at efficient and effective quality management, it's not only about measuring, inspecting, and testing. It's also about creating a system or process that optimizes outputs compliant with the quality requirements. Another element of quality is that we are minimizing waste. When we look at waste, it's one of the parameters, part of Kaizen. When we look at lean management, lean relates to minimizing waste. Less waste will also mean that we have a better quality, because we are, in fact, producing in a better way. Now, when we look at different types of waste, different types exist, and every organization can define their different types of waste. Quality, bad quality is in all cases an example of waste. When we look at project management, quick delivery of the deliverables, prevention of defects, and early detections are the result of reduction of waste. It is very important that we have elements that are delivered quickly because we can see what is going on with them, we can find out what has not been correct, and we can in fact remediate it. We also have to take into account or in consideration that we put in place systems to prevent defects. And of course, early detection, also with quick delivery. We can have early detection. We also can put early detection methods in our processes so that we can identify when there is a problem very quickly. When we look at conformance and non-conformance, we can talk about the cost of conformance. And in fact, it means that we have to invest in quality. Investing in quality has a cost, and conformance will reduce the total cost. When we look at the cost of conformance, we have two elements, main elements. First, we have prevention, which is done by making a quality product to have the processes that are, let's say, designed to create the quality that is desired. And we can do also training. We have process documentation. We have a good selection of the equipment, and we take the time to do it right. On the other hand, we have appraisal. We have to verify later. We are in fact already having products that have been produced, and we have to assess the quality. We do this by testing, destructive sampling, non-destructive sampling, and inspection. And we will look into the different tools that we can use to do this. On the other hand, we have cost of non-conformance. Failures lead to increased cost. And when we have certain elements that go out into the public, we will have, in fact, loss of reputation and in some cases even bankruptcy. When we look at cost of non-conformance, we can look at the internal failures. So it means we found the elements or we found the failure while the items were still in the company, in the factory. We can remediate them by rework or scrapping them. It has a cost. Scrapping is already a lot more cost intensive than just rework. On the other hand, we have external failures, is when those elements are found by the customer, and here we are confronted with liabilities, warranty work, loss of business, and loss of reputation. Not very good, and we try to review, or we try to reduce the cost of non-conformance by investing in quality, by prevention and appraisals. So all these things help us to get a better performance, better quality performance. When we look at some tools that exist, we can look at tools in three categories. We have tools for generating ideas, for organizing data, and for identifying problems. The first tool that we have are check sheets or tallies. Here we just look at different defects and we measure or we count the number of times that these defects happen. The second tool is a scatter diagram. Here we see the relations between different parameters. In the example, I look at the process operating speed and the process defect rate, and we have different measurements and we can find a certain trend. Here we have a positive trend, which means that when we increase the process operating speed, the process defect rate can or will increase, which is a logical conclusion because the faster we work, the higher the probability that we do something wrong. The last element here is what we call the cause and effect diagram, also the Ishikawa diagram, or my instructor called it a long time ago the Ishi-Fishi, the fishbone diagram by Ishikawa. We look at a certain effect and we look at the possible causes. There are different standardized fishbone diagrams that have been developed, and that will help you to find out where we can find issues when we are dealing with some processes or projects. Elements for organizing data, very well known, the Pareto diagram or the 80-20 diagram, where we organize the categories from high to low, and we find out which is the category or what are the issues that we have to resolve first to have the highest effect, and which is the second one, third one, and so on. Then we have flowcharts. Flowcharts give us an overview of the process, and they can provide us information about places, parts in the process where things can go wrong. Flowcharts are also used in programming, but also in process design and so on. We can identify problems with histograms. Here we put the data in also what we call sometimes a bar chart, and the data here are represented in categories, and we can have the frequencies in absolute values or in percentages. Another very important element to identify problems are the control charts, which are used in statistical process control, and we see when we have the outputs of a process, if they are between a lower and an upper control limit, we can identify when is the process in control, when do we have some issues, and control charts help us identify where things are wrong with our processes. Now, when we look at quality, we can consider many positive outcomes. We have, in fact, the deliverables which are fit for purpose as defined by the acceptance criteria. We have the stakeholder expectations and the business objectives which are met. We have reduced or at least acceptable number of defects. The delivery on target or faster. We have an improved cost control. We reduce scrap and rework. There is an increased customer satisfaction. We have an improved supply chain integration, increased productivity and profit, project team morale and satisfaction increase, decision-making efficiency increases, and finally, the processes are continuously monitored and improved. And that's a very important element because processes have to be monitored. We have to find out ways to improve the processes. For example, in Japanese companies, what the people do, some employee is given the task to evaluate, to observe some process, and they have to give a report what are the things that do not work properly. Based on that, people can improve the processes. It's not about the people, it's about seeing how the process is working, because the process should be there so that the people cannot make any mistakes. Mistakes means not being compliant with the process. If the output is wrong, it means that the process is wrong. And that's a very important element and a constant concern in today's management when we relate to quality. So that was it for this presentation about quality management, very important. Certainly today, it always has been very important, but it has an increased importance today because quality is one of the main drivers of project success. So that was it for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. I thank you very much, and I'm looking forward to seeing you in our next videos. Bye bye.